Hi everybody. So I am going to go over the Practice Chapter 9 exam, but what I'm going to do is I'm going to cover the most important problems on this test. So the most important problems that I need you to really concentrate and spend your time on is question number 1, which has to do with simplifying radicals, which is right here. Question number 2, which has to do with solving the following quadratic equations. Question number 3, which is reading a graph to solve a quadratic equation. And then I'm actually going to skip over question number 4. But I really want you to concentrate on question number 5, because you're going to see something very similar, almost identical on the Chapter 9 test. And that is all I'm going to concentrate on in this video. So I'm going to go ahead and get started with question number 1. I'm going to be simplifying the following expressions and basically going to show you my methods on how I simplify these radicals. So what I'm looking at is I'm always looking for perfect squares within each of the expressions. So one of the things I noticed is I can rewrite 32 into the following factors of 16 times 2, and therefore I know I can take the square root of 16 and I can multiply it by the square root of 2, which means square root of 16 I know is 4, and therefore the simplified expression would be 4 roots of 2. So 4 times the square root of 2. So that is the final answer right there. For letter B, again I'm looking at squares. I'm going to notice that I've got an x squared right there, and I see that I've got a perfect square that sits within 50. So I'm going to rewrite the entire expression as follows: 25 times 2 times x squared. And I'm actually going to show you that I could actually put a square root sign over the x squared just to make it easy for me to see, or maybe easy for you to see. Therefore, I know I can pull out, I know the square root of 25 is 5, and I know that that leaves me with the square root of 2, and I know that I can pull out the perfect square of x squared, which is x. So now what I do is I put this all together to make it look, as I call it, look more mathematical, which therefore means I write 5x square roots of 2. So hopefully you see what I've done there. Draw a box around it with my final answer. Moving on to letter C, you're going to remember that when I have a fraction that I could split these apart into 2 separate. So I'm going to write 12a to the power of 4 under the radical, and I'm also going to put a square root sign and go the square root of 36. I'm going to continue to simplify, knowing that I can rewrite. In fact, in this time, I'm going to go square root of 12 times the square root of a to the 4th power. And I'm going to put that over, and I'm going to immediately simplify the square root of 36 to 6. So now I'm going to tackle my numerators. I'm going to notice that I've got 8a to the power of 4, which means I can write square root of 12 times a squared all over 6. You're probably going, why am I just doing this? Why can't I just do it all together? Well, I'm showing you step by step to make it a little easier for you to see. So now I know that I could actually rewrite 12 into 4 times 3. And I've got a to the power of 2 all over 6, which means, therefore, I'm going to continue to simplify. And I know right here that I could pull out square root of 4 is 2, so I'm going to pull that out. So I'm going to say 2 square roots of 3 times a squared, and that's all sitting all over 6. I'm going to notice that I could actually simplify 2 and 6 to be 1/3, which therefore leaves me with the square root of 3 times a squared all over 3, which therefore means now I can go ahead and make it look mathematically pretty, or combine it to make it look correct in terms of notation, and I'm going to go a squared square roots of 3 all over 3. So there it is. There's my final answer. Now, could I have done that in less steps? Absolutely. But again, I wanted to show you step by step to see how I got to the final answer. And you could have simplified or skipped any number of these steps in between. Okay? So moving on. Now I'm going to be adding or subtracting, and in this case I'm subtracting a whole bunch of radicals. So remember, what is it I'm looking for? I'm looking for common radicals. So I'm noticing that I've got root 6 right there. So that means I've got 5 roots of 6, and I'm taking away from the 5 roots of 6, I'm taking away 9. So if I have 5 roots of 6, and I take away 9 roots of 6, what do I have? I've got -4 roots of 6, and then I simply bring along my 4 roots of 11 that I'm taking away. Here's my final answer. -4 roots 6 minus 4 roots of 11. This last problem, I could do a variety of ways. I can do it one or two ways. I can simplify inside and then multiply, or I could distribute. What I'm going to personally do is I'm going to actually simplify the square root of 20, which I know could be written as the square root of 4 times the square root of 5, which therefore means I can simplify this further to be 2 square roots of 5. When I do that, I notice that I still need to bring along square root of 5, because all I've done here is just brought this down, simplified, brought it down, and I still have square roots of 2 in front. Now I need to combine these two, because they both have the same root 5 right there. So I have 1 root 5, and I'm adding 2 more roots of 5, which leaves me with 3 roots of 5. Because remember, I can add these two together because I do have the same radical of square root of 5. And now I'm going to multiply this all by 2 roots. So now all I need to do is remember, I've got 1 root in front here, so I've got 1 root of 2. So I'm going to multiply 1 times 3, which is 3. Now I'm going to multiply under the radical. So 2 times 5 is 10. Therefore, I have 3 roots of 10. So that's question number 1. Please be prepared to have 5 questions very similar to these, where I'm going to be simplifying and you're going to leave them in radical form. Moving on, please remember showing all your work. Obviously, if you're doing something like this, simplifying it down to square root of 16, then I can just pull it out and get to here. Alright? So, moving on to number 2. For question number 2, this looks just like a question on the test, and it's basically asking you to solve. You've got, I believe it's 4 equations to solve, and each question is going to be worth 10 points. So I want to review that these are the ways we learned how to solve, or these are how I can solve quadratic equations. I can factor, and please remember that factoring is part of graphing, which is, this is my go-to method first. I always look to see if I can factor. Using square roots is when I have it in this format. Completing the square we did not cover in our class, so you can take that off. And then the last one is the quadratic formula. So what are the 2 go-tos that I like to use? Factoring and quadratic formula. Please remember, I will give you the quadratic formula which is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac. Okay, so that's all under the radical, and then it's all over 2 times a. So there you go. We also know that the standard form is ax squared plus bx plus c. That's typically equal to 0. We want it equal to 0 or equal to y, either way. So let's take a look and note that I've got graphs here. Why do I have graphs? Well, in case you wanted to graph to solve, because that is a method that you could use. Not the most efficient method, but it's definitely a method. So what I'm going to do is I'm going to look at the very first one, and I'm going to notice some things. I notice that I have a 1 as my a, which makes it really, really nice. So the next thing I'm going to do is I'm going to go, can I factor this? What are my factors of 10? My factors of 10 are 5 and 2 and 10 and 1. Am I able to get to 3 by looking at either one of these factors? So right here, I see that if I take 5 and I take 2 away, I get 3. So I'm going to try it and see if it works. So I'm going to set up my factoring right here. I always set it up the same way. We've done this in class. What do I know goes first? X and x. So now I know that x times x is x squared. So now I'm going to put in my factors of 5 and 2. So now I'm looking for, I know I need a plus minus configuration because I know I need to subtract these two. So, but I need a positive, so my number is going to be a plus 5. And I'm going to minus 2. So take a look. If I have 5x and I take 2x away, I get to positive 3x. Great. So now this is equal to 0. Remember, I'm solving, so I need a value of x. So I'm going to set up both of these factors to be equal to 0. So I get x minus 2 is equal to 0 as well. Solve for x. X is equal to negative 5. X is equal to 2. There you go. Those are my two values of x. I've solved it. So why did I choose this method? I chose factoring, and I'd write it out. And I'd explain why. Why did I choose factoring? So what I'm going to do is I'm going to show you my answer key that I worked on earlier, just so you could see it. I chose factoring because I saw the factors of negative 10 could add to positive 3. So that's why I chose factoring. It was easier for me. Moving on to B, I'm going to take a look at this, and first of all, I'm going to go, do I have a coefficient that's 1? No. Okay. Do I have this model of x squared is equal to d? No. Do I want to try to graph this? No. Why? Because it's too complicated. So what am I going to use? I am definitely going to use the quadratic. So I'm going to go ahead and I'm going to identify A, B, and C. So I know that A is negative 2, I know B is negative 5, and I know C is 9. I'm going to go ahead and plug it into my quadratic equation formula, which is going to be x is equal to the opposite of b, which is 5, plus or minus the square root of, I'm going to take that and square that, so that's going to be 25, minus 4 times negative 2 times c, which is 9. I'm going to put it all over 2a, which is going to be negative 4. I'm going to go ahead and continue to simplify. 5 plus minus square root. So this is going to be 25 plus. So because I've got negative negative and I've got 8, so 72 all over 4. Continue to simplify, which is going to be 5 plus minus square root of, I've got 97. Not a perfect square, all over 4. So now I'm just going to pull out my calculator. I know that I don't have a perfect square of 97, so I'm going to go ahead and immediately set up two equations. So I'm going to go 5 plus the square root of 97 all over 4. And I'm going to go x is equal to 5 minus square root of 97 all over 4. And to be honest with you, that is actually the exact solutions. So now I'm going to go ahead and use my calculator. And you can see I've actually already done the work here earlier, some work on this. So I'm going to go ahead and clear this all. And you're going to see me actually plug in 5 plus the square root of 97, which is equal to 14.84. And I'm now going to divide that by 4, which gives me x is going to be approximately equal to 3.7. That's a 3. Okay. Well, this should be negative 4. Sorry, negative 4. Negative 4. So this should be negative 3.7. So you can see I forgot my negative 4 right here. That's really critical. So I fixed that, right? So now let's go over here and do this other one. So I'm going to go 5 minus the square root of 97, which is equal to, I've got a negative there. Now I'm going to divide that by negative 4. What do I get? I get 1.21. So x is approximately equal to 1.21. So I've got my two answers right here. And so you're going to see, why did I choose quadratic? Well, I chose it because the x squared term had a coefficient of negative 2. So I just find it easier when I've got that is to make sure. You can see all the work I did up here. This is my key that I work off of. Okay. So now I'm going to move on, and I'm going to look at problem or letter C, just on the back side right here. So again, I'm going to take a look at it, and I see that I've got that coefficient of 7. So the minute I've got these large coefficients, I'm definitely moving towards using the quadratic. Well, remember, I need standard form, so I'm going to rewrite this as 7x squared plus x minus 6 equal to 0. Identify a, b, and c. A is 7, b is 1, c is negative 6. So go ahead and plug it into the quadratic. I get x is equal to opposite of b, which is minus 1, plus minus square root of b squared, which is 1, minus 4, times a, times c, which is negative 6, all over, twice a, so 2 times a, which is 14. I'm going to go ahead and continue to simplify, which means I've got x is equal to negative 1 plus minus square root of 1 plus 168 all over 14. Continue to simplify, which gives me negative 1 plus minus square root of 169 all over 14, which equals, oh man, I know that 169 is a perfect square, yay! So I'm going to go ahead and rewrite this as negative 1 plus minus 13 all over 14. So now I've got to go ahead and I've got to do my two equations. So let's set those up. I've got x is equal to minus 1 plus 13 all over 14. And I've got x is equal to minus 1 minus 13 all over 14. Continue to simplify. Therefore, x is equal to, what did I get? I got 12 over 14, which simplifies down to 6 over 7. And over here, I have x is equal to negative 14 over 14, which is equal to negative 1. So what are my two solutions? X is equal to 6 over 7, which is really close to 1, and x is equal to negative 1. So I got my two solutions. So let's take a look. Why did I choose quadratic? I chose it because the x squared term has a 7 on it. That 7 makes it much easier to factor, and I can't use x squared is equal to d because not a perfect square, plus I've got that x term, so quadratic's the way to go. All right, moving on. D. Wow, I'm looking at perfect square, move that over. I should be good, right? So I've got x squared is equal to a 144. Take the square root of both sides, which leaves me with x is equal to plus minus 12. So therefore I've got two solutions. X is equal to 12 and x is equal to negative 12. I am done. Good to go. Which method did I use? Oh, I used square roots. Why? Because I saw that x squared and 144 were perfect squares, and it was set up in the format of x squared is equal to d. So that was like a really easy one for me to see. Okay, so moving on. So now let's take a look at the next problem in our packet that I said was really important, and that is using a graph to solve. So remember, when I solve, what am I looking for? I'm looking for x is equal to. Well, I could use a graph to find the x values. I'm going to notice that I've got x right here, and then this isn't really my parabola. This is actually a cube root function, but it crosses the x-axis 3 times. So where does it cross the x-axis at? Well, x is equal to -1, x is equal to 0, and x is equal to 1. So those are my 3 solutions to my equation. Moving on and looking at B, I'm going to notice I have a parabola this time. Here's my x line, and I can see it only crosses it 1 time right there. And I notice that here's 0, here's -2, so this is -1, -2, -3, -4. So x is equal to -4. It only crosses it once. So that's my solutions for number 3, reading the graph. Number 4, I'm not going to do. I think it's valuable, but it's not anything that you're going to see on the test. But it is something that's important that you should go back and do. It's just good thinking, a good thinking problem. So now I'm going to look at question number 5. And please remember, question number 5 I told you was important. And so you really should spend some time looking at it, answering the questions, and making sure you know how to answer a question like this. So this is a word problem. It's one of those classic word problems that you see. We did a couple of these in class yesterday. You have them in your note packet. You saw it on your homework that you turned in. So there's lots of these in your textbook. So let's take a look. You've got an arrow that's shot straight up from a cliff, and you are 58.8 meters above the ground. So you shoot this arrow up, and it's got an initial velocity of 49 meters per second. You know that this shooting up is going to be positive, and you've got gravity that's actually working on the force, pulling the arrow down. So you've got the initial acceleration of the arrow is -9.8 meters per second squared. So you're given an equation. Remember, I told you you're always being given an equation. So you've got this equation that helps you identify what it is. So I've got that your height of the arrow at any point in time is of this function h of t. So h is a function of time. The height can be measured with your time. So what is it? -9.8 t squared plus 49t plus 58.8. There it is right there. You're given an equation. You're also given a graph, and this graph is showing you where you're standing at where your arrow is being shot straight up. You can see that it's 58.8 meters above the ground. That's where I'm shooting it off from. Goes up. Here's my maximum height, and then it goes back down. Here's the ground. Okay, so it says, question number, letter A, circle the point on the graph that represents the arrow hitting the ground after t seconds. So I'm going to take my pen And I'm going to circle the point on the graph that represents the arrow hitting the ground. Right here. That's where it hits the ground. So I'm even going to note it. Arrow hits ground. Okay. Now, it says, letter B, explain how you would find that point on the graph using explain and describe language. In other words, hint which method would you use in order to be able to find that? Well, obviously I can read the graph and know that it's hitting the ground there. But what am I being given in the problem? Well, you're gonna see me actually write out my explanation, and I'm going to turn this and I'm going to write the following. And you're going to see what I write, or I'm going to share with you what I wrote. Okay, because I don't want to take the time on the video to go through this. So let's take a look. I'm going to cover up the rest right here, and I'm going to share it with you. In the equation, comma, h of t is equal to negative 9.8 t squared plus 49t plus 58.8. T represents time and h represents the height. The height of the arrow can be determined at any time. The arrow hits the ground at h is equal to 0. We did a problem very similarly to this yesterday. So, at h is equal to 0, therefore, you would solve when h is equal to 0. 0 is equal to negative 9.8 t squared plus 49t plus 58.8. And you would solve for t. I would use the graph right now to show that the graph, it hits the ground after or at t seconds. So right here, at 6 seconds, right there. Okay, so at 6 seconds, that's when it hits the ground. I've read the graph. I've actually explained how I would use the graph, use an equation. What method would I use? I'm using the graph. Why would I do that? Because I know h is equal to 0 at that point in time. All right, now, moving on. Now I have to use algebra. And I have to show how you could determine the height of the arrow after 2 seconds. So, basically, I want to know what is h when t equals 2. So, I've got an equation. My equation is h of t is equal to negative 9.8 t squared plus 49t plus 58.8. So I want to know when t is equal to 2. So every place I see t, I'm going to substitute in 2. So this is what it looks like. I'm going to go h of 2 is equal to negative 9.8. I see a t there, so I'm going to put 2 squared plus 49. I've got another t. I'm going to substitute in 2. I'm going to keep going, adding 58.8. I'm going to continue to simplify. Order of operations tells me I've got to do that first, which exponents first, which means I've got negative 9.8 times 4 Alright, so what I'm doing is I am substituting, and now I'm just going ahead and I'm continue to simplify. So now I've got plus 49 times 2, which is equal to 98, and then plus 58.8. So I'm going to continue my work. Now I'm going to multiply and continue to add. So what does h of 2 equal? H of 2 is equal to 117.6. So I've used algebra to show how I can determine the height of the arrow because I used the equation. So I'm going to write a complete sentence of so take a look right here. I've already done it. At 2 seconds, the height is 117 6/10 meters. So that's the height of the arrow at 2 seconds. So now the last part says use algebra to demonstrate how long it took the ball to reach the ground. Well, remember, take a look up here. We read the graph that the arrow hits the ground at 6 seconds. But now we're going to prove it by using the algebra. So remember what we did. We said that the height is 0. So 0 is equal to negative 9.8 t squared plus 49t plus 58.8. Okay, so now take a look. Well, I'm not going to factor this. What am I going to do? I'm actually going to use the quadratic formula to solve this, to solve what is t. So I'm going to say x is equal to, right? And I'm going to identify a, b, and c. So let's go ahead. A is negative 9.8. B is equal to 49. And c is equal to 58.8. So go ahead and substitute all of those values in to the quadratic equation. Gives me x is equal to the opposite of b, which is negative 49, plus minus the square root of 49 squared minus 4 times negative 9.8 times 58.8. Oh, I'm going to have some big numbers here. All over 2 times negative 9.8. I'm going to continue to solve and simplify. I get negative 49 plus minus square root of 2401 plus 2304 all over negative 19.6. Continue to solve and simplify. I get negative 49 plus minus the square root of 4,705 all over negative 19.6. This is where my calculator definitely comes in handy. So let's go over here. Once I plug all of the information into the calculator, I get two values for x. I get x is equal to negative 0.99999. And I get x is these are all approximate values, obviously, right? Is equal to 5.999. So if I round that, x is approximately equal to 6. There you go. I solved it using the quadratic. I also solved it using my graph. So I'm good to go. Right, so now everything else in here you should definitely work on, especially this functions. Pretty straightforward, reading the graph. You should do just fine. I'm not going to go over this. The only thing you can't do is this last piece. Okay? So, if you weren't able, I'm hoping that this was helpful and that you will do well tomorrow. Tomorrow when you walk into class, we're going to get started on the test immediately. Hope you have a good evening, and please let me know if you have any questions whatsoever.